So I'd like to welcome everybody to this session of the webinar series on the rapid studies from ELISE. My name is Robin Smith from the Joint Research Centre, and we're recording this session, and for that reason we'd like to give Danny the chance to give the presentation of this work from start to finish, and if you want to raise any issues you can in the chat. The context of this work is in the European Location Interoperability Solutions for e-Government, ELISE Action of the ISA² programme. It's the only geospatial action, and within that, Danny, myself and other colleagues are looking into the concepts of knowledge transfer that help with capacity building and raising awareness about the digital transformation of government and the role that location interoperability and geospatial solutions can play. So in that contract and work with Key 11, and we're looking into a series of rapid studies to try to break new ground in certain topics, and in the team we discussed how persistent identifiers, also based on previous work as Danny will mention, is potentially an artifact that allows organizations to discuss how they're managing that data and sharing and linking it with others. So in this case, following other studies that we've been doing, the work itself is mainly technical because there's a number of technical issues, but Danny will also touch upon some more organizational and cultural ones. So to save time and to basically let you hear the substance of the talk, I'll now pass on to Danny, please.
Okay, thanks, Robin. I hope you hear me fine. Yeah, before I start the presentation on PIDs themselves, I briefly introduce something about me as a speaker. So I'm a research manager at the University of Leuven, Saddle, in Belgium. My background is geographer, so I'm a geographer, that's my background. I was involved in different roles in work related to standardization and spatial data infrastructure implementations, mainly in the OGC and also in the ISO and the CEN committees, respective committees. And then I played also a role as a member of the board of directors of AGIF, the Flemish Agency for Geographic Information. And now I'm also external innovator expert for the Council for Information and ICT Policy of the Flemish government. So I was involved in several more practical and also more study-oriented projects related to INSPIRE, but also specifically focusing on standards. One of those projects is still ongoing for the European Environmental Agency, and some of the work that has been done there by my colleagues is also part of this presentation. In teaching, I'm teaching various courses, but mainly vocational training. And of course, I have a series of publications with focus also on INSPIRE implementation. What I will say or state in this presentation is my view based on the rapid study, of course. It's not in any means a position of the Commission or any of the organizations that I will mention. Also, before starting the real presentation, already some maybe key messages that I put in this presentation. In fact, the idea is that persistent identifiers, whatever form they take, are a key component of any spatial data infrastructure, but also are key in digital transformation of governments. We know that there are different kinds of identifiers, of which URIs have been mostly used in our own fields, especially in the context of publishing data on the web. And we also know from experience that poorly implemented and managed PIDs can lead to problems of exploitation of the data and especially also the data sharing. Furthermore, PIDs are essential for also trying to link spatial data to other data information on the web, and in fact also in the other way around, so to link data on the web to spatial data that can be found there. And finally, another message that I want to put forward is that member states should really carefully consider all the aspects of PID implementation, It's not only about the design, the architectural aspects, but it's also how to governance it and how to manage it. Okay, first I will introduce briefly persistent identifiers. What are they? What are the different types of PIDs? Why are they so important? And how PIDs are important or relevant in the context of spatial data infrastructures and INSPIRE in particular. In fact, identifiers are almost everywhere. You have identifiers for persons, a name of a person, a company, but a person has also an identity card with a number, a unique number in a country. Companies, they are registered, they have a specific dedicated number, buildings, cars, motorbikes, bikes, and of course also spatial information, whether it's in the form of data sets, documents, data objects. Everything has, in practice, an identifier. Some examples are given here in this page, and you can also already notice an important difference. So identifiers can refer to real things like persons or a car that exist in reality. So they are physical objects, but they can also be virtual objects, like, for example, the name of a municipality. You can't necessarily see the boundary in physical space, but it's there, it's defined somehow. But it can also refer to the representation of the objects in information systems, and more particularly on the web. So that's already an important element. I provide here some more formal definitions of OMG and also definitions that can be found on Wikipedia. So let's say that identifiers in general are names or labels that identifies either unique objects or unique classes of objects, where the object can be anything, an ID, a physical object, or a physical substance. So that's how it is defined by OMG. But you will find also, if we browse on the web, many other definitions. We'll not discuss them in detail here. They are just given here for the sake of completeness. Often you also will find the term unique identifier referring to the fact that an identifier should be something unique. And then usually we refer to a numeric or alphanumerical string that is associated with an entity in the system, and so that it can be addressed and accessed and interacted with. That's a definition of Rouse, quite recent definition. Okay, that identifiers in general, but we mentioned already identifiers in the context of the World Wide Web. There are some challenges, of course. We all know that there is a lot of information on the World Wide Web, and it contains very diverse information that changes. It's not comparable. Some are in document formats, other are code lists, etc., images, videos. So it's very diverse. So we need, in general, mechanisms to correctly identify, for example, a data set or parts thereof. That was one of the findings or initial reasonings of a study done under ARENA in 2014, and the publication is from 2015. In the context of INSPIRE and SDEI in general, of course, identifiers are also a key ID because we work at dataset level or dataset series, but also at the level of the objects within the datasets, it becomes relevant. But in the context of infrastructures, also other elements or mechanisms such as the metadata to describe the data, the web services, code lists, data specifications, etc., they can all have unique identifier and persistent identifiers. So what is important is that when we publish something on the web, independently from the time when the publishing took place or takes place, then it's important to have a kind of identifier that refers unambiguously to the same resource over time, and that it is persistent in the sense that it is a long-lasting reference to a digital resource. So it's not something that is changing over time. That are the key elements through them. One is the globally uniqueness. Ideally, that should be the case. Of course, in many contexts, it's more regionally implemented. They should be persistent, as we mentioned already, so they should be assigned once and continue to be assigned to that resource for a longer period. They should be resolvable. It means that the identifier should finally lead to the available resource, although it might be that the resource is protected or part of the resource is protected. That's still possible, but at least information should be available how and to which degree the resource can be reached and accessed. It should be, of course, also be reliable. It means that the organization that manages the PIDs should commit to keep and maintain the PIDs. And then provenance is mentioned often. It means that over time, the PID solution or mechanism should be guaranteed, meaning that the organization should keep it ongoing, the organization that issued the identifier. Then there are a few other requirements that were mentioned at that time in the ARENA study, which is we should look into cost effectiveness, so it should be free of charge if possible or at very low cost. It should be supported by policy, so it's not one organization or person or department that invents it, but it should be supported by policy level. And it should be preferably managed by embedded processes and procedures. Then other requirements is on interoperability, granularity, and versioning. Interoperability can entail many aspects, syntactic, semantic, and also community interoperability. It means that at least interoperability is guaranteed in a certain community. Granularity refers to the level of detail at which persistent identifiers will need to be assigned. And then the versioning is that the PID solution should support the changes that can affect an object or its context. So the authority, context, and the object itself. Okay, that were some elements from previous studies under ARENA. But since its beginning, the INSPIRE initiative has always looked into the aspect of PIDs and the implementation of ELISE. It has been described already in the basic documents of INSPIRE, why it's important to apply a mechanism of unique identifiers and what are the benefits of using URIs, for example. URIs are important because it was said that URIs are already part of the web technology in general. They are based on proven technology. They're also based on a common framework for different types of data. Machine readable also, and relatively easy to deploy, and they have usually a similar and very familiar structure. And it means also that they allow, and that's typical for spatial data infrastructures such as INSPIRE, that they are enabling the deployment of federated governance procedures. They can be used to provide access to the individual objects, to data sets, but also to other aspects, as it was mentioned before, of the whole web infrastructure. So in that sense, they are quite transparent and far-reaching, and they have an impact not only on INSPIRE, but on the way INSPIRE can be integrated in the overall web and in digital transformation of governments. The figure to the left indicates or provides an example that was already given in one of the documents of INSPIRE, where in fact INSPIRE and spatial data infrastructure refers in general to real-world objects, like in this case air monitoring stations, have then abstraction and concepts in a data model, and the data model or the data can then be served in different formats, for example, and they can be on different places in the web, and they should be uniquely be referred to through the unique identifier. So, in fact, PIDs or ELISE have been a focus and a point of attention in Inspire and SDIs from the very beginning. Now, what are the challenges in PID management, but also setup, of course. So we look briefly into what others have experienced, and then we will dig a little bit deeper into a specific case that has been the subject of a study for the European Environmental Agency. So in the former study that I already mentioned, that took place under ARENA, one important element to mention is that it took different perspectives on PIDs. I don't mention here anything about the financial aspect, but it was covered as well in that study. But there were three other areas that are quite important and should be taken into account when setting up a PID mechanism. It's the governance of it, so you need a PID policy. You need also kind of organizational approach, who is responsible for what. You need to look into the operations, so the registration of PID, the validation, the redirection, and the long-term preservation of PID. So there are all kind of important operational aspects. And then, of course, there are the architectural aspects which relate to the naming, the design rules, and also the service model. So it's not just a question of defining correctly a URI string, but a lot more is important here. So you have different perspectives: governance, operations, and architecture. That was an important outcome, and there were some conclusions from that study. And I mentioned only a few here in this slide because there are a lot more in the original reports that are mentioned in the reference list. Under governance, for example, organizations should together look into the processes and the procedures, but also who plays which role, what are the responsibilities, liabilities. That's one important recommendation, to look into all these aspects. Another recommendation was to ensure enough flexibility and inclusiveness, so to apply the policy not to few organizations, but government-wide, and also not have only expertise, technical expertise, but also the decision-making level into the game. That are important aspects for governance. For operations, we can say that PIDs consist of those many things: the registration, validation, redirection, etc. And one of the recommendations that came out of the study was to use SLAs to guarantee high level of availability, also good performance and reliability of the PID system or mechanism. Another recommendation was to provide enough guidelines for the organizations that should help manage the PIDs. We'll come back to that when we discuss the example of Belgium and the Netherlands. And then finally, regarding the architecture, also there it involves several aspects. There are many PID design options that can be applied, used. And when we see examples, then you often see different ways of doing things. The interoperability between the different solutions is maybe not entirely clear yet, but gradually, by having more and more examples, they are converging to the same way of doing things. It would be an idea that came out from the ARENA study to look into or to develop a PID-specific interoperability framework, something comparable to a Parsons framework, which is for research data, to which was referred in that study. And then, of course, another aspect in the architecture is to look into PID management tools and services. I stop here because I see that there's... Robin, do you hear me still?
Yeah, I hear you fine now. I had a problem before, but we're good.
Okay, I continue. In a workshop that took place only 10 days ago on the metadata, it was called Making Spatial Data Discoverable Through Mainstream Search Engines. Also, in the different interventions and presentations there, it revealed, or it confirmed, in fact, that IDs and the use of URIs are still a current problem. It's not something that is completely solved. It was very striking that it's not a few member states that are looking into this, not only in the context of INSPIRE and spatial data infrastructures, but also in the context of digital transformation. And it is clear that it's part of the efforts of member states to make their data in general, their things, more discoverable and easy to use, also through regular search mechanisms. So we all know the geodata portals that we use in the context of SDIs. We know the open data portals, etc. But more and more people, users, and also developers use regular environments or engines. And it's in that context that that workshop took place. And as part of the interventions from different countries, Finland, France, Italy, Poland, the Netherlands, but also in other countries, we see that they are carrying out efforts to make the data more discoverable, but also to look into new ways to define and design URIs. For example, in Finland, they are working on a national recommendation or recommendations for spatial data URIs with a fixed pattern that they recommend. In France, BRGM has observed that not all data providers have a URI strategy, and therefore they worked on a kind of strategy or mechanism or architecture with different scenarios, so that could cover and host different types of data providers with different practices. And they intend to roll out this approach to be applied to data sets, services, but also the metadata about the data sets and services. So efforts are made at that level in France by BRGM. In Italy, the eGov, or the information branch of the government, they also observed limited use of URIs in general, and also they think that it is very useful to use URIs in particular contexts. For example, to uniquely identify different types of data licenses, for example. They observe that, for example, in the metadata, in INSPIRE and spatial data infrastructure in general, descriptive text is used rather than a fixed code list, for example. Also, GeoSeer, that developed and that is a tool for searching spatial data and services on the web. They also mentioned or highlighted the importance of PIDs, especially to avoid the problem of duplication of metadata records that they entail or discover when using their tools. Same in Poland, where they look into the application of URIs for individual objects, and also the Netherlands, where they have done GeoNovum as well as GeoCat, the developers of GeoNetwork, activities around unique identifiers. The figure here is one of the schemas that BRGM wants to implement with some examples for datasets related to boreholes. Then I shift to our own experiences with ReportNets. Where there was a feasibility study carried out by the European Environmental Agency related to Natura 2000 spatial and non-spatial data. As you know, the European Environmental Agency is responsible for reporting on the status of the environment, and the Natura 2000 data are related to two directives, namely the Bird and the Habitat Directive. And member states report a lot of spatial and non-spatial data through different e-reporting mechanisms, and they upload data on a portal of the European agency. It's called ReportNets. And the feasibility study that was carried out was in fact part of the modernization efforts of the EA of this ReportNet mechanism or infrastructure. And so the idea is that in that way also the reporting itself can be streamlined and be simplified, let's say, especially at the side of the member states, because it's a big burden to annually provide the necessary information, not only for this directive, but for many other directives. So what were the objectives of this feasibility study is to use data harvesting techniques to access data at the national level and even local level without requesting then member states to report them, so that this schema could replace in fact part of the work by the member states. And to access the spatial data through by using Inspire standard web services, so making use of the Inspire infrastructure. More specifically, there were two use cases linked to those two specific objectives. The aim was to demonstrate the viability of the harvesting workflow of complete data sets, so harvesting of data sets for environmental reporting, and then also to test the possibility to reference, find and download specific spatial objects that are required for different environmental reporting obligations, also both through the Inspire infrastructure. So the latter is a little bit new. It's even not a subset of a data set, selecting that and then download that part, but it's really try to find a particular spatial object. Lessons learned from the spatial data set harvesting is it started in practice from the Inspire GeoPortal, which helped in some cases, in most cases, for the member states to find the right data set. But there was a need to do a little bit additional programming to try to automate a little bit the search mechanisms, which were a little bit cumbersome, and most important, it was sometimes very difficult to find complete results. For example, sometimes there were several services for the same data sets, etc., but also sometimes different types of download services, so it was not always clear which was the authoritative one. In some cases, there were several ones because national data sets were disaggregated, so you have different services for different regional or sub-data sets. Sometimes data sets were mixed with non-related content for reporting obligations or maybe for other reasons. So it meant that the search for finding the right service, a download service, and then the right data was not so straightforward as one could think, and it was necessary to have additional search refinements and ultimately to get confirmation from what is called in ReportNet a national reporter, who is the official person who can state that a data set is the official and final version for a given year. So it meant it was interesting, it worked generally speaking, but one of the conclusions was that the better Inspire implementation happened, the better the quality of the infrastructure, the metadata, but also the services and the way they work, the better also the results of the search. Below you see a BPMN schema of the future revised flow of data delivery to the EA, where you see in the upper swimming lane the member state that should only prepare and publish the data as is being done in, amongst others, Inspire, and then most of the work and activities or the task are then carried out by the EA themselves by the harvesting mechanism. So if everything would work fine and is complete, and would be operational, then there would be a shift of work from member states to European level. The other use case looked into searching for particular spatial objects, which was called officially referencing geospatial objects. Again, it worked on Natura 2000 sites, making use again of the INSPIRE network services. And in that case, several steps were defined. As is the case for the harvesting use case, also this use case has a separate report, by the way, and it is referenced at the end of this presentation. There were several analytical steps, so to analyze the content and the data models behind Natura 2000 data. Mostly Natura 2000 data are what we call the spatial, the standard data forms, in which the descriptive data, it's a very rich database about Natura 2000 protected sites, are described, so they're only partially geospatial. Then there is also a link to data that is hosted and gathered and maintained through the Water Framework Directive and the WISE system, so the Water Information Systems in Europe. But some of them, they correspond to objects in Natura 2000. And then, of course, in INSPIRE, we have the protected sites data sets under Team 9 of the INSPIRE Directive that can be downloaded through web services, web download services. Analytical work was also done to check the link between those different data sets, especially for the identifiers, and also to analyze the capabilities of the available INSPIRE download services in relation to direct access download services, and how features could be downloaded. And then some testing was done using these WFS services for downloading, and several alternatives for linking data in INSPIRE to the right Natura 2000 feature was carried out as well. The schema is given in the right. Maybe it's too technical details, so I will not go into details, but roughly speaking, from the Water Framework Directive to Natura 2000, the link could be made relatively easy, but there were several issues when trying to link Natura 2000 with INSPIRE objects in INSPIRE spatial data sets. So the workflow was done detailed. The analysis was done as was presented in the previous slide in different steps. What was striking indeed was that the link between Water Framework Directive reported data and standard data format data was quite straightforward and successful, so very reliable, almost 100%. But in case of Natura 2000 standard data forms with INSPIRE datasets, unfortunately there were several issues. And that relates probably to the fact that usually, can you still hear me?
Yeah.
Okay. I just from time to time check because I'm not sure. Okay. But that at the level of Natura 2000 standard data forms and INSPIRE datasets, sometimes there were issues like at object level in both data sources and in INSPIRE downloads service WFS. So the first step was to be sure to use the right download service, but then several issues were encountered, like for example, in only 1/3 of all the Natura 2000 sites that included the values for the INSPIRE spatial object identifier, which meant that the connection could not be straightforward be made. While some countries provide this information systematically for each Natura 2000 site, for other countries this field was left empty, so that gave a problem. Also, the structure or the way the INSPIRE spatial object identifier was handled differs a little bit. The INSPIRE identifier is a complex element which is composed of a local ID, namespace, and a version ID in some cases, because that's optional. And so most member states include only the local ID part of that identifier. In some other cases, this was concatenated. So namespace, site codes, and map inspire field was all put in one string. So the implementation is done different by different member states, which resulted in a series of issues. So what are the lessons learned and a few recommendations derived from this work? It's all described in more detail in the report. So one of the conclusions that is that if the Natura 2000 data correctly includes Inspire ID, then of course it's also straightforward and it's easy to harvest the targeted spatial objects using the WFS. While Inspire defines a complex data identifier, SDF, so the standard data forms only use a single field, which is usually done in different ways. So we think better guidance should bring the solution here for member states. Then there might still be errors, of course, typing errors, whatever. Therefore, also the reporting data flow at the level of ReportNet would still need to include a check of the link for each of the individual sites. In general, also, we think that there should be better guidelines and quality control checks on the field Inspire ID in the Natura 2000 datasets, so that could improve also things. And while the standard data form defines a unique site code of each site that can be used as a link, if it is included in the Inspire dataset, that would make things even easier. And some data providers are already doing that, but we realize that is a little bit out of scope because that's not foreseen in the Inspire specifications. At the end, 7 download servers were really tested using the Inspire protected site simple application schema and providing data with the Inspire ID. 4 WFS servers were providing or could be reached, the data could be reached according to alternative schemas. So in the report, we also gave a few general recommendations or ideas for improving things, and that would facilitate certainly referencing geospatial objects. Okay, this example was to provide an idea of the challenges that are still on our plate, on the table. And therefore, I will end this presentation by focusing more on what we consider best practices for PID implementations. So we looked into in more detail in 2 cases, mostly in the Flemish case, but in Belgium, but also in the Dutch case, which is quite similar. First of all, if we look into the Flemish URI approach, it's a broader approach. It's not focusing only on a general strategy. In the case of Flanders, for example, the focus of the strategy is on how to define URLs for websites of the government. And then they have 2 other documents, namely URI standard and URI guidelines, which explain the standards with examples. So first was in fact the URI standard developed in 2017. The guidelines were developed also in the end of that year, and the URL strategy, which is not entirely related but builds further upon the standard and the guidelines, was adopted at the end of 2018. What is very specific or very best practice in our opinion is the way they worked. So it was a co-creation approach, which is also one of the ideas of digital transformation of governments, where it was not decided by the higher levels of the authorities, but local authorities were involved, private partners, academia, the departments of the Flemish administration, and then a specific initiative for standardization, which is OSLO, Open Standards for Linking Organizations, which is the organization which is most closely related to the ISA efforts. And everything was steered by the Steering Committee for Flemish Information and ICT Policy, under which there are different working groups, namely one on data and another one on standards. Also very important was that time was taken to develop the approach and to develop also the documents. It started with a study, a desktop study. Then there were different discussion or working groups with the different stakeholders from the different sectors. Then there was a draft of the URI standard and guidelines and a public review period. And then it was tested, the standard as well as the guidelines, in specific settings, namely on basic registries for addresses, organizations, and the road register, and then also the public service register, which exists in the Flemish administration. And then finally, it was published, adopted and published and voted. So it was voted by the community in that steering committee. And then it was also translated. So you can find the two documents in English on JoinUp. And also, as a last step, there was a public webcast. So generally speaking, from governance and organizational point of view, this was an interesting approach, and it seemed to work well. By the way, the URL strategy is also a document that has been formally accepted by the government at the highest level. The best practice for PIDs, or the URI standard maybe first for data resources. So I put here the front page in Flemish, but you will find the same in English on JoinUp. So the Flemish URI standard describes how to design correctly URIs. So the focus of that document is on 18 rules and sub-rules for defining correct URIs. Here is the general pattern for persistent URIs, with the URI is the full string consisting of a namespace, a reference, and in the namespace you have a domain name, the type of URI, the concept, and then of course, as I said, the reference to the resource. So the URI is applied in the standard as the formal way to refer to the resource. And this URI should be resolvable to find the resource back, that's clear, and it is described in detail. I will not go through all of them because that's maybe a little bit too technical, but I will pick out a few examples. So the rules for the URI standards relate to general design aspects and specific rules, how to define the domain, the type, the concept, and its reference. So there are in general 7 high-level rules and 11 more detailed or sub-rules. Just to have a few examples, the first one, rule 1, is that HTTPS or HTTP must be used as the base for the definition of the URIs. The pattern is as I described before. Another one, for example, R5, is that a concept as part of the URI pattern should represent the category of a resource, and it can use a hierarchical classification list, but that is not mandatory. That's, for example, one of the requirements in the standard. The more detailed rule example that you find on the right part of the slide is R43. It says that for each URI of type ID, and an ID is that refers to an object of the real world, so it's not a representation in the system, but it's the real IDs, for example, the car or the building. A similar URI of type doc must exist. So when you have a URI type ID, you should also have a URI type doc that refers or might eventually refer to URI where the actual document can be found. The further you dig down, it means that in the requirement it says the latter one should not necessarily follow all the design rules. So the upper level should follow the rules, but the lower level ones not necessary. So the standard is complemented by guidelines, so describing in 8 relatively easy to understand guidance principles how you implement and apply the design that is described in the standard. And also, again, organizational aspects are referred to, and it is in fact based on the 5 to-dos and 5 not to-dos on a good design of PIDs or URIs developed some time ago by ISA, that you see in the picture at the right. Also there I will not explain them all, but for example, guideline 1 says that the URI domain should be always the responsibility of the organization that provides the resource. And then guideline 2 is a very simple one. It is agreed upon that the highest top-level domain is data.flanders or Vlaanderen.be. And then you have several ones that are related to specific implementation of the pattern that I showed. Maybe also guideline 3 is an important one, because it is allowed to work with subdomains, but it is advised that the subdomain is put after the slash, for example, roads, wegen means roads, so that the information on roads can be found under data Vlaanderen.be/wegen. But it can be done in different ways. So you have in some guidance different ways of doing things. In the document, there are several examples listed and analyzed of existing URIs. And to the right, you see one example. So the first URI that you see provides an overview of data sets on the city of Ghent regarding birds. So everything regarding birds in the city of Ghent that you find back in the upper one. If you would really apply the rules or the guidelines, then you would do it as it is described in the lower URI. So that's an example that is provided in the guidelines, but there are more examples given. So the guidelines are meant to apply the standard by giving guidance and examples. Finally, a few words on the URL strategy and also on how specific agreements have been made regarding URI's implementation in the context of SDI and Inspire. So in general practice, as we stated before, and that's a starting point for this strategy, is that websites and applications of the government are usually mixed with other websites when a user is trying to find information, not necessarily data, spatial data sets or spatial objects, but in this case to reach specific websites. In case of websites that resort under Vlaanderen.be, then if you would use Google, then usually the websites are ranked high, but even then it's not always clear whether you deal with an official website or not. So therefore, the Flemish government at the highest level decided to develop a strategy and to implement it. So currently it has been adopted end of last year, and it entered into force beginning of July this month. And then there is a transition period of 4 years because there exists a lot of departmental or public websites, other websites. And so the entities must comply with the strategy, but there is a kind of flexible way of transferring towards an URL that is more stable and according to the rules. Some implementations are quite complex and it would require a lot of modifications to reach the new standard or agreed design. As technology Akamai was chosen, and also procedures have been set up for the development of new websites. So new websites initiated now should follow the strategy and the rules defined there. And also some of the conditions are indicated in the strategy, for example, regarding style, security, privacy, etc., etc. And the existing ones can be gradually transformed. So this 4-year time period is available for doing that. And Information Flanders, so the government offers for all departments and municipalities that want to adapt, offers a development environment and a test environment. And in fact, it can be run by the entities that are responsible for their own web pages and websites to do so. So that's an organizational flexibility that's built in. And then finally, in Flanders, there should be a few words on URIs in the context specifically of Inspire. And that's in fact something that has been initiated at the federal level, and that has been implementation has started by the regions and by the federal government. As we know, in the context of Inspire, there is the obligation on data harmonization where possible and interoperability of data sets and services. That's a requirement, and there is specific legislation for that. And in that context, there were some discussions on the use of URIs, specifically for Inspire and for these supporting these implementing rules. And since there were in some documents, some documentation guidance of Inspire, there were some changes made, namely regarding the use of URIs. It was decided to look into that. So it was decided at federal level to have a dedicated working group on identifiers. So the Belgian Interfederal Inspire Coordination Committee brings together federal partners that are involved in Inspire, and then the regional ones, so the Flemish region, the Walloon region, and the Brussels region. And in fact, originally in the generic conceptual data model for Inspire, only URN schemas were suggested, but now that was revised into 2014, I think, or 2013, to the URI schema. So that was then translated, or is being translated by each region and the federal level. And in fact, in Flanders, it has been taken care of by referring to the GDI decree, SDI decree, which is in fact the decree that transposes Inspire. So there are several pieces of legislation there to apply URIs to all data objects of the data resources and to apply the URI schema as defined in the standard and explained in the guidelines. But indeed, it's not mandatory. So it means, in fact, that for new URIs defined, organizations will apply it, but existing URIs that do not fulfill completely might continue to exist. And also, it is only partially or not mandatory to all aspects of the SDI, because in some cases only part of the data set falls under the Inspire directive and is being affected by the harmonization transformation efforts. Interesting is the details are not provided, but after or during the public consultation round, it was revealed that the impact of this prescription, as it's called, is quite limited. And so at the federal level, that we should take into account when thinking about the Flemish case, the principles that were agreed upon for URIs in context of Inspire were decided amongst all the partners involved. And in fact, the URI approach allowed a federated governance model for this definition, managing and maintaining of the identifiers. So everyone agreed, all the partners across intra-country borders. So there was consultation and coordination, and there was kind of agreement between all stakeholders to apply the example, the best practice developed in the Flemish region already. So that's important to take on board or home after this webinar. But when digging deeper also into the Dutch case, then we saw also a good practice or best practice in our opinion for PIDs. In fact, the Netherlands and in particular Geonovum did already huge efforts in the past, already in 2013, where they developed already a first initial national URI strategy for linked data for the Dutch public sector. And in fact, recently that has been further picked up and developed, but broader. So it's not only geospatial anymore, but it's under what is called the Digital Framework for Environmental Law. All the stakeholders came together, e-government is involved, and they have together, collaboratively, co-creation, developed this approach. So it's not only environmental, but also other national departments and agencies, the provinces, municipalities, regional water authorities, etc. And also they involved in the development and of the strategy, private and academic sector, because the reasoning is also that this will also affect well, all public authorities, but also citizens and businesses, and then in particular also ICT developers. So they have a very interesting URI strategy document. I didn't find it in English, but it might exist, so that's still to be checked. So in the document you will find the basic design of URIs, including the schema, authority, pathway, everything. Also the application of the design rules in case of web pages and user applications. A series of rules for SOAP web services and for REST APIs, rules for linked data implementations. And then there is details about all the individual components, including even security. Everything is defined there. And also they tackle issues related to versioning, formats, and there are some general agreements. So in total there are 39 requirements. And also the document is interesting from the perspective that it is provided, that examples are provided on how to implement the requirements. Here are some examples. For example, there are 34, so I didn't list them all. But an example is the design of URIs follows Internet Standard RFC 3986. In case of REST API URIs, it must define the security context. Also, in case of URIs for linked data implementations, their URI types are fixed, so there are 3 possible values: ID and doc, like we already referred to. ID is a real-world object, and doc is document, and they call it resource, but that can be also a vocabulary, etc. So there are several aspects in those requirements further developed and detailed. What is important in this document is how to treat the aspect of time. For example, as part of the strategy, the stakeholders agreed that in case there is no specific date given, then the most actual information for a resource is provided. In case the date is given, then it is provided as part of the query component. And in case a specific date is given, distinctions made between valid on, available on, and active on. So that's based on another ISO standard, 8601. And then also regarding formats, there are specific agreements on mechanisms for content negotiation and how they format things. So from that perspective, and also the way they explain the upper right figure is they look not only from the data perspective, but they look into APIs, the services, the applications, linked data implementations. So everything is looked at in one single document. Okay, some conclusions. So PIDs and what's geospatial role towards digital transformation. In fact, in the geospatial area, PIDs have been used or applied already for some time. And that was driven mainly by the need for better managing and sharing the data. That's one important observation. It means also that often this experience involves transformative activities where multi-actors are active and contribute. It's not surprisingly, because spatial data infrastructure and Inspire are networked approached with multi-stakeholders. And also in this case, you see that for the URI approach, they include collaborative and joint strategies, and they agree after very, well, not long processes, but very detailed processes, and they try to be inclusive and to agree on standards, guidelines, etc. So if we want to put data more on the web and make it available in a more easy way, then the readiness to share data with the wider community is key, and therefore PIDs will play a key role. And it is also obvious that these efforts will be more and more use-driven, and also co-creation approaches to further develop these efforts should be in the middle of everything. Finally, the geospatial has a lot of experience in general to offer, not only on these PIDs, but also ways of delivering and sharing. And therefore also the way spatial data infrastructure are set up and the way forward and implementing things by testing and experimentation might be very relevant for digital transformation efforts across borders. And then I will end with next steps, but for that I hand it over to Robin.
Well, first of all, thanks very much, Danny. I really appreciated you covering quite a lot of ground here to do with the, not only, let's say, the theoretical developments, but also some practical experiences that you've managed to bring together and share us in the context of these rapid studies. I forgot to mention at the beginning, I give you very little time to actually execute the work and try to bring together these examples. I'm very grateful for that in the first instance. And as I mentioned, this is a part of a rolling series of studies. We've already had a look at what is digital transformation with Danny's colleague Glenn, and we recently had another presentation about the role of APIs, where this one on PIDs is another technical example. But just to let everybody know, towards the end of August, maybe the beginning of September, we plan to have quite a different study that's taking place and being prepared on the background, looking at examples of issues around citizen science, VGI, and participatory democracy, where geospatial has been active in recent years. Of course, this is quite an open process. We're discussing with some stakeholders in Inspire and the ISA² program, but anybody else who would like to participate and provide inputs to what they think would be a sensible topic about the role of geospatial in the digital transformation of government, we'd be very interested to hear from you, and we share the link here on this site where you're able to follow and register for each of the events. I'm going to pause the recording here in case there's further discussion, because we're running a little bit over in time, but again, many thanks to Danny and colleagues for the work on this effort, and I'll close the meeting shortly.